Hello everyone, welcome to another AP Computer Science video. In this video we're going to continue our discussion of multi-dimensional arrays, and in particular two-dimensional arrays, because that's the primary focus of the AP exam. Even though we can do any kind of dimensional array, two-dimensional are the most commonly used, and the exam will focus a lot on their applications. Last time we talked about dynamically allocating two-dimensional arrays with the new keyword, just like one-dimensional arrays. We talked about accessing values. We can use the same index notation. We can also use the length methods, and we talked about the fact that when we say the 2D array.length, we're talking about the number of rows. And then if we access one of those rows and call .length again, we get the number of columns. Or another way of interpreting it is being when we call .length on our original variable, we get the number of subarrays, and then the length of one of those subarrays is how many items are in those arrays. We said that the AP exam is going to assume that our two-dimensional arrays are rectangular, meaning every row has the same number of columns, or every subarray has the same number of values, which is not always true in the real world, but for the AP exam we can make that assumption. And then finally we saw how to make literal two-dimensional arrays, and this is kind of proof of the idea of an array of arrays, where the outer braces are the primary array matrix, and then each value is itself an array of values, in this case integers. So what we'll do here is we're going to make a new class. We're going to do a more explicit example with the usage of a two-dimensional array in a particular fashion. Now, I'm not going to say this is the best implementation when it comes to a complex system, but for our example, it's a nice usage. So I'm going to make a new class in our array stuff package, and we'll call it grades 2D arrays, 2D array. And so I'll go ahead and make a main method inside of it using our shortcut. And the goal of this is going to be to have a small program that reads in information from a user and then generates some things. So what's going to happen is we're going to ask the user, how many students do you have? And they'll tell us some number. And then we'll ask them, how many grades do you want to keep track of for each student? And then once we've accepted this information, they'll have to type in all these different values. We will print out the average for each student. And this is an approach we're going to take to make this work effectively. So let's try this out. So first things first, let's make a scanner so we can interact with the person through the keyboard. This is something we've done before. With our system.in, so this is a connection to our console, whatever that may be. And we do need to fix imports to make sure that our scanner is recognized through our program. And so the first thing I'm going to do is I'm going to ask them right off the bat, how many students do you have? And I'm going to make some assumptions to save time. I'm not going to worry about bad input. I'm going to assume they're going to give us integer values. They're not going to give us negative numbers, things like that. We could do that, but I'm not going to. For the sake of ease. It's more about the array stuff, not necessarily about the input. So let's go ahead and put in a message, and we'll say something like, enter the number of students. I enter that number of students, oops, and then they're going to type it in, so we have to accept that, and so we'll say num students is equal to kb.nextInt. And remember, nextInt returns whatever they typed as an integer, and we can go from there. We'll do the same thing for the number of grades per student, and we can maybe put another message. And we'll say enter the number of grades per student. And then we'll accept that value, and we'll call it numgrades kb.nextInt again. So there we go, we've accepted two pieces of information, how many students there are and how many grades they have. In terms of our two-dimensional array, what have we been given? We can use these values to set up our array pretty easily. If we visualize our two-dimensional array as each row being an individual student, or representing the grades of a student, and each column in each row as the individual grades themselves. And so that's how we're going to set this up. And so we need to make our array, or two-dimensional array, have num students rows and num grades columns within each row. So let's go and do that. Our data type, think about what's an appropriate type for grades. There's more than one answer, but I'm going to stick with one. just because I think it's the most fair or flexible one, and that's a double, because it's possible to get a 95.5 or an 87.5 or something like that. So decimals is not a terrible idea, and if we're going to eventually get averages, it's not a bad idea to display or to have them as doubles so we don't have to do any conversions or casting on our own. So let's go ahead and try this. We'll say our array, 2 dimensions, and we'll call this grades, is a new 2-dimensional array of doubles, and it has num students rows. Remember that first value is row major order, so the first is how many rows there are, or subarrays, and then each subarray or each column, each row has num grades columns, and there it is. And so now we have our empty 2D array. Just like with 1-dimensional arrays, the default values for primitive numeric types is 0. So this array is filled with zeros initially. If it was booleans, it would be false. If it was objects, then it would be null references. But for primitive doubles, ints, floats, and so on, it's the 0 value. Now that we've done this, we can start to fill it in, but it requires us to do input in a repetitive fashion. We need to ask, well, for every student, enter the grades for that student. So we have to repeatedly go through students, and then for each student, we have to repeatedly ask for grades. Now, how many times are we going to do this? We don't have to use a while loop because we know how many students they want. They told us, num students. So let's make a loop that repeats num students times, right? So we'll make a regular for loop. We'll say I is equal to 0, I is less than num students, and it goes up by 1 each time. And so what does that mean? So if num students is 5, we're going from 0 to 5, not including 5, which is 0 to 4, which is 5 times. So it's just about the count. It's not necessarily about the index itself. And so let's go ahead and put out a nice message. We'll say, these are the grades for the first student, and these are the grades for the second student, and so on. So let's put out a message, something like grades for student. And I want to put the number. So what I'm going to do is I'm going to kind of attach I plus 1 to our message, and then that way we can, actually I'll just do it like that, it's better like that. And then I'll put an extra line underneath it, and we'll talk about this in a moment. This is just a visual thing. But so for example, if we're at index 0, then I'm saying the grades for student 1, and then if we're at 1, we're at grade for student 2. So the naming is just so we don't start at student 0, because that's not a typical approach to numbering things. Typically we start numbering from 1, and it's just a visual thing. So that's the students. So we print out the message, and then now, what do we have to do? We need to repeatedly ask for however many grades they told us they want. And in this case, they told us it is num grades amount. So yet another loop. Right, we're going to find ourselves constantly nesting loops when we're dealing with 2-dimensional arrays because we have to do with 2 layers. The row layer and the column layer, or the subarray layer and the value layer. So it's always useful to be aware that nested loops are pretty common when it comes to multi-dimensional arrays. And the more dimensions, the more nesting you would end up having. We're doing 2 dimensions, so we end up with 2 nested loops. So now let's repeatedly ask for a grade, take it in from the keyboard, and store it in our array in the appropriate place. So I'll use another regular for loop, and I'll start with j being 0, j less than num grades, and j going up by 1. So that's, again, num grades is 7, and we're going 7 times. If it's 10, we're going 10 times. If it's 2, we're going 2 times. And now our message is enter a grade. And then we will absorb that grade as a double, so we can take a fractional number. And we can use kb.nextDouble because it does conveniently convert for us. And so we've taken in the grade they type, and then we got to put it somewhere. So now ask yourself, what row and what column does this current grade for this current student belong? Which grade are we on? Which student are we on? And what are those values as indices to put it appropriately in our grades 2-dimensional array? So if you think about it for a moment, hopefully we recognize that we are on the ith student, so every outer loop is a new student. So if I is 0, we're on the 0 student. If we're on 1, it's on the second student, and so on. And then for any one student, we are on the jth grade. If j is 0, we're on the first grade. If the j is 1, we're on the second grade, and so on. So this current grade is the ith student jth grade. So we're going to use I and j as our indices. So we can say grades at I, j is equal to whatever our grade happens to be, right? Ith student, jth grade. Right? Our rows represent students, our j's represent the grades for each student. And so at the end of this loop, we have the grades for each student. And in fact, that's pretty much it for the input portion of our program. And there it is. And so with this, we've accepted values. And of course, we don't see anything. We just type them in. And then we're going to have to test that by displaying the content. My goal next is to display the average for each student. So why don't we make a method that accepts a two-dimensional array of doubles and prints out the averages for each of those students, assuming that every row is a student like we've been doing. So I think this is a good attempt, a good practice, because 2D arrays, just like regular arrays, can be inputs to methods. There's no limitation. It is a new data type. It's not really new. It's just another array, but now the content is arrays with values inside them. So it's just another step in complexity, but really the same content. So outside of our main, let's make another method. And we'll go ahead and say it's public, it's static. We're not going to return anything. I want to instead print directly. So it's going to be a void return type. And we'll call it print student averages. And the input is the entire collection of grades for all the students, which is a two-dimensional array of doubles. So just like before, we can write our data type, which is a 2D array of doubles, and then we have to give a variable name. Let's go and call this, temporarily we'll call it st grades. Again, the name doesn't matter. I could have called it grades. There's no conflict. It is a different scope. And so if we print, well, before we print them, we have to first get the summation of the grades, divide them by how many there are, and then print them nicely and so on. So we'll make some assumptions here, again, just for the sake of ease, because we've done averages before. This is not particularly difficult. But we'll say that we'll assume that there's at least one grade in every row, so we don't get divided by 0 errors and things like that, right? So let's go ahead and say, look through every row. So now I'm going to do it a little bit differently, and this is on purpose, and I know it's not going to be the best approach just because we're going to end up having to make an extra variable somewhere along the way for display purposes. But I want to use enhanced for loops so we can see that even though we've used enhanced for loops for regular arrays, there's nothing that stops us from using them for arrays of arrays. If a two-dimensional array is an array of arrays, our enhanced for loop can do the same thing. The only change is that the data type itself will be an array. So let's try this out. We'll say for, and again, I'm going to say it in English. Typically when you read an enhanced for loop, you say for every value of the type in the collection, in a particular collection, do some work. And so our values are arrays of doubles, because the two-dimensional array is an array of arrays. Each of those subarrays is an array of doubles. So we're going to say double array, and I'll call this cur student in st grades. So that is the same as the I loop on the outside. We're going per row. Each row is itself a subarray, an array of doubles, right? The total two-dimensional array is st grades, and we're saying look at one row in it, and cur student represents that row. And now we can do the same thing in cur student. And again, I'm going to use an enhanced for loop just because, so we can see it in action, how convenient it can be. But again, we're going to end up having to do a little bit of extra work to make it look nice the way I want to. But still, it's just good practice. So another enhanced for loop, of course, we need to have a variable to sum our average. So let's do that first. We'll say double average is equal to 0. And now we're going to say for every double, and we'll call it GRD, in our current student array. Oh, cur student. I'm sorry, cur student. What are we doing? We are adding them to the average, and then after the loop is over, we will divide by how many there are. So we'll just simply say average plus equals whatever the current grade is. So notice we've used two enhanced for loops. They're still nesting, but here notice there are no indices, which is okay mostly. But now when I want to display my nice average, I'm not going to have an index to refer to, so I'll have to do some extra work if I wanted to say something like, oh, student 1 average, student 2 average. So we'll have to kind of put up with that. But that's okay. And after our loop is over, we can simply get our average and say our average is equal to what it was divided by, And now, how many grades were there? We're still within this outer loop, and that outer loop represents the current student, which is a subarray. The number of items in that subarray is how many grades there were. So I can simply say per student length. So if there were 5 grades, we're dividing by 5. There were 10 grades, they're divided by 10. If I had said stgrades.length, that would be the number of rows, which would be the same as saying the number of students, which is not correct to what we're trying to do. And now finally, we need to print out that average. So I'm going to say system.out, and I'm going to say student, and again, I want to show a number like student 1, student 2, student whatever. And unfortunately, I did not make a variable, so I'm going to make one now. I'm going to call it stnum, and I'll make that a top. So student number, and then we'll put a colon, and then we'll attach their grade, which is average. And of course, now I need to make stnum. We'll do this at the top because every row is a single student, so we'll say int stnum is equal to, we'll start off at 1 because instead of having to do the I+1 trick at the top here, we can say, okay, well, print out whatever student you are, and then of course update the num by 1. So the next time it comes around, it's 2, 3, and so on. And so we should see student number 1 average, right? Okay, I should put the word average. There we go. There it is. And there's our method, right? So for every student or every row in our 2D array, calculate an average from the sum of the individual grades within that subarray and display them. So the final step is to call this method in our main after our asking for the grade. So here it is. So now we can say display grades, averages. And we'll say print student averages, and simply we pass in the 2-dimensional array called grades. And that will do this heavy lifting that we just created. So let's test this out. We'll start small and then we'll try bigger. So I'm going to run the file. And so enter the number of students. Let's say there are 3 students and they have 3 grades per student. So there's the grades for student 1. Enter a grade. Okay, let's put 100 for the first grade, 100 for the second grade, and 100 for the third grade. So this first student has a perfect score. So the reason I do this is so we can validate the average should be 100. Let's go try something else. Student number 2, we'll say they got a 75, a 95, and a 95. Right, and number 3, they got a 100, a 60, and an 84.5. And there we are. And we can see that correctly, the 100 average is correct. The average of these 3 numbers is an 88.33, and the last one is an 81.5. And so there it is. Right, a very complex program. I mean, not too much going on, but the idea of using this giant grid of numbers as a helpful setup is not a bad idea. And again, could we have designed this in another way? Absolutely. We could have maybe made classes that represented students, and then students could have an array list of grades within them, and that could be very flexible and dynamic. But the takeaway is that 2-dimensional arrays really are just arrays with a little bit of more complexity. It's like an extra layer, but really they're just arrays, right? An array where the values are themselves arrays. So we'll stop here in this video, and we'll try some other examples in the next video. But really we should be comfortable with 2-dimensional arrays and 1-dimensional arrays. I believe that if we look at the percentages, a good chunk of the exam, the AP exam, is primarily array manipulation, reading through arrays, summing values, looking at data in arrays and moving things around. I think it's something like 15% is 1-dimensional array questions, and another 15% is 2-dimensional array questions. So that's almost a third of the test just on arrays, and that's quite a bit. It's almost guaranteed that 1 or 2 free response questions will use 1 or 2-dimensional arrays in them. It's almost guaranteed. So you have to be comfortable with this topic if you want to be successful on the exam as well. So I'll see you in the next video. If you have any questions, please reach out to me. I think this is an important topic to be comfortable with before we move on.